Just like how we have the law of sines, we also have something called the law of cosines. There are three ways to write the law of cosines depending on which side you're focusing on. But I always remember like this, that the law of cosines looks an awful lot like the Pythagorean theorem. Pythagorean theorem says a squared plus b squared equals c squared. But the law of cosines has this extra piece that's taken away from it. Right? And the piece that we have to remember is the minus 2ab cosine of c. Right? Notice that this last term starts with a 2, but it's got the a, the b, and the c in it. But that c is not side c. It matches with the c that's on the other end of this equation. But that c is the angle c. So if we shift our focus from that angle c or side c to side b, then when we're creating the right side of this law of cosines, we're going to need the other two sides, so a squared and c squared, and subtract off 2ac cosine of angle b, so that the angle and the side match up on the ends. Then the third variation, of course, would be 4a squared. And my other two sides would be b squared and c squared, minus 2bc cosine of angle a. The proof for this can get fairly complicated, a little bit beyond the scope of our Algebra 2 class. So you're going to have to trust me on this. If you want to see the proof, just Google proof of law of cosines, and you'll find a lot of good videos and resources there. But let me show you how to use the law of cosines in order to solve this triangle. As you know, when we're solving a triangle, we want to identify all of the angle measures and all of the side lengths. And looking at our diagram, it looks like we have angle B is 36 degrees. And we have that side A is 7 and side C is 5. So we need two angles and a side to complete this triangle. Well, what I'm going to do is use side B first. That's where I'm going to focus my attention. So using the law of cosines, I'm going to use the one that starts off with b squared. Right, b squared is going to equal the other two sides, a squared and c squared, minus 2ac cosine of b. So a was 7, c is 5, and angle B is 36 degrees. Since everything's all on the right side, we can just go ahead and type that all into our calculator. And you get 17.3688. But be careful, that is not the length of side B. If you look at our diagram, B is not the longest side. Right? That side A is our longest side. So we shouldn't have B being 17. That's because that 17 is really B squared. So in order to solve this, we do have one more step that we have to do, and that is to take the square root of both sides. When we do that, we end up with a more reasonable answer of 4.1675. So B is going to be 4.167. Once I have this pair between angle B and side B, now we can shift over to using law of sines. That the sine of B, 36 degrees, is related to B in the same way that the sine of either angle is related to its side. So I'm going to use angle C. So the sine of angle C is related to side C, which is 5. To solve this one, I'm just going to multiply both sides by 5. I'll get those guys to cancel. And so sine of C is going to be 5 times the sine of 36, all divided by that 4.167. And we get 0.705. That's not our angle, that's what the sine of the angle is. Remember, to get rid of sine, we're going to use sine inverse of 0.705. And when we do that, C is going to equal 44.829. So 44.829 degrees. The last step of finding angle A, to find A, we start with the 180 degrees that make up all triangles, subtract off angle B, and subtract off angle C. And we're left with 99.171. And remember, that's an angle, so that would be in degrees as well. We have another triangle to solve, and this is the first time we've had one that doesn't have any angles in it. Like, I know all three sides. I know that side A is 16, side B is 9, and side C is 10, but I don't know any of the angles. We could still use our law of cosines to help us out. And when you're using a law of cosines to find an angle, and you got your choice of any of the three to use, it's going to be best to search for that largest angle measure first. So that's what I'm going to do. I'm going to look for angle A, which means that in my law of cosines, I'm going to start with A squared is equal to B squared plus C squared minus 2BC cosine of A. Now be careful as you're solving this. You know what to do. You know how to do this correctly, but so many times I see people do this. They take their calculator and find out what all of this is and call that the coefficient that's being times by cosine of A. And that's not right. What you need to do instead, just take it small pieces at a time. Like that 16 squared is 256. 9 squared is 81. 10 squared is 100. And then 2 times 9 times 10, that's 18 times 10, or 180 cosine of A. Now, when we start adding things together on the right side, 81 plus 100 is 181. That's true. But this is not 181 minus 180 that's being multiplied by cosine of A. It's only the 180 that's being multiplied by cosine of A. So these are not two like terms. We can't combine these two terms. We have to treat them separately. It would be very similar to having an equation that looked like 256 equals 181 minus 180x. Right? You wouldn't combine those and say that there's only one x. So don't do that when we have cosine of A in there either. Right? Instead, what we want to do is solve this like we should, like we know how to do. Subtract 181 from both sides. So 75 is equal to negative 180 cosine of A. Then divide both sides by negative 180. 75 divided by negative 180 is negative 0.416 repeating. And that's what the cosine of A is. To find A, we take the inverse cosine of negative 0.416 repeating. So if I use the answer key and just go inverse cosine of the answer, we get that A is 114.624 degrees. Once I have that angle, now I have a pair. So we can go back to using the law of sines. The sine of angle A, 114.624 degrees, 4, is related to side A, just like the sine of B is related to side B. So I'll multiply both sides by 9. And to find B, we're just going to take the inverse sine of that decimal. So using the answer key, that 9 sine of 114.624 divided by 16 is going to be 0.511. And when I take the inverse sine of that 0.511, we get 30.753. Now, when I say I'm using the answer key, I mean that on my graphing calculator, instead of taking these decimals that are cut off to 3 decimal places, I use a second and the negative sign in order to come up with the exact answer, the larger decimal, to reduce round-off error. Of course, my last step then is to find out what angle C is. So I'm going to start with 180 degrees, subtract off that 114.624, and subtract off the 30.753, and we're left with 34.623 degrees. Real quickly, checking that our largest side is paired with our largest angle, smallest side is paired with our smallest angle, and that's the solution to our triangle. So how about a word problem? From a remote-controlled sub, the following measurements are taken. How far below the boat is the shipwreck? So we can see that we have our sub off to the side, and it measures the angle to the boat as well as to the shipwreck to be 70 degrees. And it can also tell that it's 520 meters from the boat, 338 meters from the shipwreck. But we don't know what this third side is. So we can use our law of cosines. Remember that it starts off looking like the Pythagorean theorem. The side we don't know is going to equal the sum of the squares of the other two sides minus 2 times their product times the cosine of that 70 degrees. When we calculate all of that out, we get 26, 44, 17.0792. Of course, that's not x, that's x squared. So we have to take the square root of that answer, and we get something like 514.215, which seems like a much more reasonable answer. Of course, we're not finished yet. That 514 is not just 514, it's 514 meters.